So if you have been following this series, we have talked about a story of a town with two shops, a piece of information being given about their sales. Shop A sold 300, 250, 400 in last 5 years, 2015 to 2019. Similarly, for shop B also, the number of units being sold over the same 5 years has been given. We convert this piece of information into tabular form like this. So using this piece of information, let's go ahead. So what is this that we are talking in this video? We are talking about multiple graphs. So we will see some questions where we'll have more than one graph or one sort of data presentation to give you more information. It could be a combination of a pie chart and a table, or a bar graph and a line graph. It could be anything, or maybe bar graph and bar graph as well. Doesn't matter, it could be 3 graphs, whatever it is. So you have some piece of information, we are trying to give you more information in multiple graphs, etc. The problem in these questions, right, fundamentally what you'll see is the basic data representation stuff only, like the bar graphs, the pie charts, the line graphs, etc., what we have already discussed in the earlier videos. But the important concept that you need to understand or build in this for this set of questions is, how can I link the graphs that are being given? Like if I give you bar graph and line graph, what is the relation between the information that I see in both? Sometimes there could be no relationship, they are two individual pieces of information. Sometimes there will be a relationship connecting couple of elements in bar graph, the graph 1 and graph 2, which you have to really understand. Students get confused or they sort of miss the point or the logic. So when you see the piece of information, before you deep dive into the question, sort of try to understand both the graphs and see if they're two independent graphs or if they have anything in common and anything like connecting point, and what is that. Once you understand that, it's easy to solve the questions. Let's look at the same piece of information, right? Just to make it how the information could be given, I'm just trying to convert this into two different graphs, like graph 1 and graph 2. What is this graph 1? It's talking about, it's showing a pie chart showing the percentage of sales over the 5 years for the entire town, which is basically shop A plus shop B. All the while we have not talked about this. Let's assume there are only two shops. So in 2015, shop A sold 300, shop B sold 250. So that is, the town as a whole has seen a sales of 550, 600, 350, 500, etc. Right? Let's assume I don't know this. Let's assume I don't know this. I only know the shop A units. That is the graph 2 talking about. Right? In 2015, shop A sold 300 units. 2016, shop B sold 250 units. Right? So on is given in the graph 2. From this graph alone, can I comment on the shop B? No. Hence, I cannot even comment on the entire town as well. But they have also given for the graph 1, which is the pie chart, which is in percentages. 22, 22, 24, 14 and 20 percentage. That's the total sales, a percentage wise for each of the year. If you just see this, as we have already discussed in the pie chart, with the percentages alone, I cannot comment the actual sales. If you ask me in 2016, how many units were sold in town? No idea. The answer is cannot be determined. I cannot give you a certain answer. I just know that the total sales, whatever the total sales be out of adding all 5 years in the entire town, I should be, making 22% of the total sales in the year 2016. That is what this 22% is. I don't know what is the total sales, hence I cannot give you the actual sales in 2016. For that reason, you'll also have a clue like this. The total number of units sold in the town is 2550. Now I know that the entire unit sold in the town is 2550 over the 5 years. So how many units did the town sell in 2016? That is 22% of 2550. So that is 22 by 100 into 2550. Right? 5 2s are, 51s are, 2 11s are. So what am I getting? 11 1s are 11, 11 5s are 55 plus 1, 561. Right? This is what I'm getting. So if you see, it's 550 in 2016. This one is because these percentages are approximated. Technically, you should be seeing 21 point something in decimals, but the graph is basically approximated. If I add up, you see 22 plus 22, plus 24 is 68, plus 14 is 82, plus 20 is 102. The whole thing is coming as 102%, right? That's because the values are approximated while this graph was constructed. You won't see that happening in the actual question, so don't worry. I'm just showing you, but that is how you do it. Once I do the individual percentages, I know in 2016, let's say in 2016, 561 units were sold in the town. How many units of Shop A were sold? 250. This is something I'm reading from graph 2. From the graph 1, I read that the 560 is the total number of units sold in 2016 in the town. Right? Shop A in 2016 sold 250. So how many did Shop B sell in 2016? To 561 minus 251, that is 311, something like this, right? The actual answer should have been 550, so minus 50, 300. That is what this is. But I'm just, have done slight approximation, so it's okay. The point is this. That is the logic of connecting the graph 1 and graph 2, right? The graph 1 and the total number of units sold is going to give me the town-wise sales. That is this piece of information. And the graph 2 is talking about this piece of information. If the question is asking me how many units were sold by Shop B in 2016, I should subtract this minus this to get this. That is the relation between the graph 1 and graph 2. Be clear with that, right? That's what I'm saying. You should understand what piece of information is given in both the graphs and how they have some connection in between them. That is the complexity, or that is the key point in multiple graphs.